Okay, we're going to talk about electric field, okay, which is sample D on page 574. We're going to skip the calculation, but in general, electric field is some object, whatever it might be, has a whole bunch of charge on it. Say a bunch of positive charge. And I bring another little test charge, Q, over here. Bring it in next to that charge. There'll be some electrical force in between them equal to the total charge there on the left times our little test charge divided by the distance between them squared. Okay. Now, electric field is what if I take away this individual charge here and I just worry about what's going on with this other guy. So my electric field is going to be that electrical force divided by my little test charge. So I would get K Q1 Q over D squared, and then divide by that little Q. So that cancels out. We'll just get our original charge from our object divided by the distance out to our test charge. And it doesn't depend on the test charge at all. Okay. So this is the thing that actually creates the electrical force, is this electric field. So if I had a point charge sitting in space, like a positive charge, and I showed these lines of force, these electrical field lines, they would extend out in every direction from my positive charge. Likewise, from a negative charge, the field lines would point inward towards the charge. Okay, and everywhere in space, these lines would try to connect. A positive will try to meet up with a negative. So this electric field extends through space, but it extends in every direction out into our test charge. Okay, and it will gradually fill this space. Okay. Even lines from way out here start to turn in towards that other charge. We'd get a pattern sort of like this, if we could see it visually in space. Now there's a similar drawing to this on page 577. 577. We have a positive charge meeting with a negative charge. In the case we had two positive charges, both of those are creating a positive arrow coming out of the charge. But these electric field lines will never cross. So as they start to approach each other, these lines actually turn and diverge away from one another in the center region. Can we get a pattern that looks kind of like this? They try to fill the space, but never cross one another. And we get an asymptote line in between them where they never cross. And then extend more regular out on the backside. Okay, but they never cross with a like charge. Okay, positive charges like negative charges. And in this case, say I had a plus 3 charge, plus 3Q over here, and maybe only a minus Q over here. So I would denote that by lots more lines, 3 times as many lines from the 3 as, say, from the little Q. Okay, everywhere I'd go out, even stronger. More lines, more strength.